So January 2019 paper, I did question 1 from this. So question 2. So this is question 2 from Jan 2019. So the question is, an ester C was hydrolyzed by heating with sodium hydroxide. The resulting mixture was distilled to give off an organic liquid D. The residue was acidified and the mixture was produced an organic liquid E is there. So first we have ester, and when we do hydrolysis of the ester will produce carboxylic acid and alcohol. So first part I will discuss unit 6, and then alternate weeks I will explain revise unit 4 and 5 and do the question in the third part of the session. So we have ester C is there, which we hydrolyze by heating with sodium hydroxide. So as a result, the resultant mixture was distilled off an organic liquid D is there, and the residue was acidified and the mixture was purified to produce an organic liquid E. Spatula measure of phosphorus 5 chloride, PCl5, because whenever we do hydrolysis, it will produce carboxylic acid and alcohol. So PCl5 is a test for check the presence of OH. So even it's a carboxylic acid or alcohol, it will give a positive result with both of them. So both give off the steamy fumes are there, that is hydrogen chloride, and turn the damp blue litmus paper red because the acidic is there, hydrogen chloride is acidic. Identify by name or a formula the gas produced and the group which are, so the gas which is produced, that is hydrogen chloride, HCl, and the group which is present in the molecule, that is OH. Because this is actually a test to check the presence of OH. Then D was oxidized to produce carbonyl compound. They said what additional information this give about D. So if substance can be oxidized, oxidation can happen for uh, primary or secondary alcohol, like carboxylic acid cannot be oxidized. So it give an idea this is an alcohol. So deoxidized to produce a carbonyl compound like C double bonded with O, either a ketone or an aldehyde. So what this give an idea, because when we do hydrolysis of the ester, it produces alcohol and carboxylic acid. Alcohol can be oxidized, carboxylic acid cannot be oxidized. So this give an idea that this compound is alcohol. But which specific alcohol, because even not all alcohols can be oxidized, primary or the secondary can be oxidized. So this give an idea, either it is a primary or secondary alcohol. So D we identify it's an alcohol. In the mass spectrum of a D, the molecular ion peak is at 60. So it means the molecular mass is 60. Which alcohol is having a molecular mass 60? The general formula for alcohol is CN, H2N plus 1 and OH. And the total is 60. So carbon is 12N plus hydrogen is 2N plus 1 plus oxygen is 16 plus 1, and total should be 60. So when we simplify, 14N is equals to 14N plus 18 equals to 60. This will be subtracted. So 14N is equals to 60 minus 18, which is 42 divided by 14. So N is equals to 3. So this gives an idea that there should be 3 carbon atoms in this alcohol. And 611 means like the relative intensity should be 611. So we have carbon Like either it can be primary or secondary. But if I draw primary, then what is the relative intensity? The relative intensity should be 3, and there will be 4 hydrogen environment. This is one hydrogen environment. This is second hydrogen environment, third hydrogen, fourth. So, but we want the 3 hydrogen environment. So it means it cannot be primary. So the second one is it can be secondary. So if it is secondary, the OH attached here, the CH3, H, and then CH3. These two CH3 which are there at the end are identical. Like this is CH3, this is also CH3. So this is one hydrogen environment, this is second hydrogen environment, and third. That's why the relative intensity is 611. Like here total in A there are 6 hydrogen, in B there is 1, and C there is also 1. Is it clear how we identify it as secondary, not a primary? Then aqueous sodium hydrogen carbonate is added to E. So sodium hydrogen carbonate or hydrogen carbonates are tested to check the presence of acid. So acid plus carbonate gives salt, water, and carbon dioxide. Identify by name or formula the gas which is produced, so that is carbon dioxide, and the functional group which is present, that is carboxylic acid. So E is carboxylic acid, and the for D was propane 2-ol. E is also having a molecular ion peak at 60. So the general formula for carboxylic acid CnH2n plus 1 COOH, and the total should be 60. So 12n, because one carbon is 12, 12n plus 2n plus 1 plus 12 plus oxygen 16 into 2, 32 plus hydrogen 1, to total should be 60. So this was 14n. This will be 32 plus 12, 44, and then 46 will be there. So this is 46 is equals to 60. Because the general formula for the carboxylic acid CnH2n. So when we work out the value for n, like 60 minus 46 divided by 14, so n is equals to 1. So if n is equals to 1, because it is C1H3COH, so it is ethanoic acid. Because like CnH2n plus 1 COH, so one carbon is already there, value of n is 1. With value of n is 1, and there is another carbon for C double bonded with O and OH, so it is ethanoic acid. So we identify it, and you have to draw structural or a displayed formula. Structural formula, we represent minimum detail, but the displayed formula show all the atoms and all the bonds. Draw the structure or displayed formula of ester C. So ester C is formed by propane 2-ol and ethanoic acid. So C double bonded with O and O. This part is attached with a carbon chain. So OH will be removed. So the second carbon should be attached with oxygen. And then you have to just put hydrogen. And this one is there, like then another carbon, because it will be propyl ethanoate as a product. So this will be the structure, because the alcohol was propane 2-ol and acid is ethanoic acid. That's why it will be propyl ethanoate as the final product. Question 3, this question is about a compound of manganese in different oxidation state. Describe what would you see when aqueous sodium hydroxide is added to an aqueous solution containing manganese 2 ion and a mixture is left to stand for few minutes. So when we have manganese, as a result, what will happen? It will give off white precipitate, and these precipitate, when we leave it, they will become dark. So in the beginning, white or off-white precipitates are there, and they will turn into dark, like the color intensity increase as the oxidation number change. So first it will be white PPT because of manganese hydroxide, and then turn dark when we leave them for, this is there in unit 5, the identification of the ions. A sample of aqueous potassium, a sample of aqueous solution of manganate 7 ions prepared from an aqueous solution of manganate, a sample of aqueous solution of manganate 6 prepared from aqueous solution of manganate 7 and the solid manganese 4 under appropriate condition. Choose the appropriate standard electrode potential of a cell for a formation of manganate 6 ion in acidic solution. So this is in alkaline because OH, when you see this OH, so it means this is alkaline solution. We don't have to use that. It is in acidic solution. If the So how to work out the one which is a higher value, because it is reduction minus oxidation. So the one which is a higher electrode potential, reduction happen, and the one which is a lower electrode potential, oxidation happen. So electrode potential of a cell, the standard electrode potential of a cell, it is redox. Just remember, from redox means reduction minus oxidation. And how you identify which one reduction happened? The one which is a higher electrode potential. Why I did not take the second equation? Because they mention in bold, it's written acidic condition. Means there should be a protons. But here, the second equation is in alkaline condition, so we don't have to use that. That's why we did not use that. So reduction minus oxidation. So reduction was 2.26 minus oxidation was 0.56. And then explain why, like, this is what should happen. Like, according to the equation, reduction minus oxidation. So electrode potential will be 1.7 volt. So if electrode potential is 1.7 volt, what does it show? It shows that each oxygen here is -2, so 4 will be -8. So manganese is +6. And here manganese is +4. So for this will be reduction, and here MnO4 with a charge -1, so this is +8. Each oxygen -2, 4, +7, and then MnO4 with a charge -2, so -8, so this will be +6. So this should be reduced and this should be oxidized, means the equation should happen in other way around. So they're asking, choose an appropriate standard electrode potential to calculate the electrode potential of a cell for formation of manganate 6 ions. So we want the formation according to this equation. So means, like, when we apply the electrode potential of a cell, which is reduction minus oxidation, it means that we are getting a positive voltage. So it means if this reaction happen, then manganate ion +6 ion will not form. Actually, what happened? +6 will change to +4, and which is reduction, and then +6 will be changed to +7, which will be oxidation. So there will be no formation of a +6 if this reaction happen. So use the calculate the cell to explain why manganese 6 ions cannot be prepared under acidic condition. So why it cannot be prepared in acidic condition? Because the idea is that the one which reduction happened, that is always forward, but oxidation will be the reverse reaction. So when we work out the electrode potential, reduction minus oxidation, so here +6 will turn into +4 and +6 will turn into +7. So it means if this happen or reaction happen, Mn +6 will not form, or we can also say like the electrode potential for formation, because this is not the formation, so formation will be minus 1.7 volts. If we work out the standard electrode potential, it will be 1.7 if Mn6 change to plus 4 and plus 6 change to plus 7. So it shows that this reaction does not produce Mn6 ions. In this one, Mn6 ion turn into plus 4 and plus 7. Is it clear, this part? Explain in terms of standard electrode potential why manganate 6 ions can be prepared in concentrated alkaline. So it's why we can prepare it in concentrated alkaline solution. So if we take this one, if you see which one reduction happened, the one which is a higher electrode potential. And which one will be oxidation? The one which is, because it is reduction minus oxidation. So this will be reduction because a higher value, and this one is oxidation. So this reaction will happen here. Mn each oxygen is minus 2, 4 will be minus 8. So and total charge we need minus. So this is plus 6 will turn into plus 4 reduction, and here it is plus 6 and turn into plus 7. So this will be reduction, this will be oxidation. So still when we calculate, like it is reduction minus oxidation, so 0.59 minus 0.56, which is 0.03. So if you have 0.03 volt, because it's reduction minus oxidation, so 0.03. So it shows that this is still in this one, like less likely Mn plus 6 will form, because electrode potential, we are getting a positive electrode potential when plus 6 change to plus 4 and plus 6 change to plus 7. But why still there is a chance is there that it might form, because it is a very low voltage is there. So forward reaction and backward reaction means can both happen. If the voltage is very small, it means both possibilities are there, like Mn7 can turn into Mn6 or Mn6 can turn into Mn4 or other way around. The next is an outline procedure for finding the amount of a dissolved oxygen in a pond water is given. Shake 100 cm cube of a pond water with manganese 2 hydroxide in a closed container. The manganese 2 hydroxide is oxidized to manganese 3 hydroxide. Then we add excess of acidified potassium iodide. The manganese 3 ions are oxidized. Manganese 3 ions oxidize iodide ion into iodine, and they will be reduced back again. Then titrate the iodine with 0.0 mole per dm cube thiosulfate. Then repeat the titration until the concordant titration are obtained. State a suitable indicator. So usually whenever whenever iodine is there, we use starch as an indicator. And in the beginning, like if iodine is present, it will be black or purple. And when iodide ion is there, it will be colorless. So in the beginning, we will have iodine molecule. So this will be blue-black, and this will be colorless. So indicator, we use starch for iodine, and initial color will be blue-black, where final color, it will be colorless. Following this procedure, a mean titer was 16.2 cm cube was recorded. Calculate the volume of dissolved oxygen in cm cube in 100 cm cube of a sample of a pond water. So how we work out, look, you have the you have the volume and concentration, original concentration. So you'll get the moles of thiosulfate. From moles of thiosulfate, we'll get moles of iodine. From moles of iodine, we'll get moles of Mn plus 3. And from moles of Mn plus 3, we'll get moles of oxygen. So we have to use a ratio multiple times here. So using a concentration, you have the volume and you have the concentration. So use moles equals concentration into volume. And this will give you the moles of thiosulfate. So 0.01 times the volume 16.2, but it is in cm cube, we have to convert into dm cube. This will be moles of thiosulfate S2O3, which will be 1.62 into 10 to the power minus 4. Then we'll take a ratio between thiosulfate. We'll take a ratio between thiosulfate and iodine molecule. The ratio between them is 1 is to, the overall equation when you check, the ratio is 2 is to 1. So if the ratio is 2 is to 1, like 2 moles will be 1. So if we have 1.62 into 10 to the power minus 4, so this will be x. Cross multiply. This will give us the moles of iodine, which is 0.0, like 8 point, it will be half of it. So 1.6 into 10 to the power minus 4. So it will be 0.81 into 10 to the power minus 4. That is the moles of iodine. After getting a moles of iodine, we'll get the moles of Mn3. And again, we'll use a ratio from the equation. The ratio between iodine and Mn3 is 1 is to 2. So iodine and Mn plus 3, the ratio is 1 is to 2. So if we have 0.81 into 10 to the power minus 4, so this will be x cross multiply. We'll get the same answer, which is 1.62 into 10 to the power minus 4 mole. Then after getting the moles of Mn3, then we'll take a ratio again. Oxygen and Mn plus 3, I think it was 1 is to 4. Yeah, 1 is to 4 is there. Because the moles of Mn3 is same as moles of Mn hydroxide. So Mn plus 3 moles and iodine and oxygen moles is 4 is to 1. So 1.62 into 10 to the power minus 4. So this will be x. Cross multiply. You will get the moles here. It will be divided by 4. So it will be 4.05 into 10 to the power minus 5 mole. And then multiply by, because these are the moles of oxygen, multiply by molar volume, which is 24 decimeter cube or 24,000 centimeter cube. So we'll get as 0.97 centimeter cube, or it can be in decimeter cube as well. Is it clear? So question 4, I think there are 4 questions in this. Question 4 we'll discuss next time. Now I'll explain unit 4.